in this paper of 0625, paper 1, paper 41, October, November 2025. So I need just to go ahead and add the code here, 25. Yeah, so which means that we are going to have a discussion on how you're supposed to approach some of the questions that are appearing here. Now here we are told that a train travels with a constant velocity of 56 meters per second, and the horizontal on a horizontal track. The mass of the train is 440,000 kilograms. We are supposed to state the difference between velocity and speed. So something that you need to remember is that velocity is a vector quantity because it has both size and direction, while speed is a scalar quantity because it has only size. So I defined velocity as a speed in a particular direction. And from there we got the definition that velocity is a vector and speed is a scalar quantity. We need to look at part B, and part B you are being asked to calculate the kinetic energy stored in a moving train. So what you ought to remember here is that kinetic energy is equals to half times mass times speed, velocity squared, or speed squared. So if you substitute that into the formula, you are going to get the kinetic energy stored is going to be 6.9 times 10 raised to power 8. Part C, you are supposed to calculate the constant braking force. And since there was a uniform deceleration, then we can be able to use the formula force is equals to mass times acceleration. Now, in this case, our acceleration is the deceleration, which we have here. And the mass of the train was 440,000. So if you work it out, you're going to get the force that was stopping this train to be 5.3 times 10 raised to power 5. Calculate the distance traveled. Have to remember that work done is equals to force times distance, and work done is equals to the kinetic energy we had gotten from the previous section, so that we can be able now to substitute at the point where we have the work. And if you work it out, you're going to get 6.9 times 10 to the power 8 over 5.3 times 10 to the power 5, which is going to translate to 1301, which is approximately 1300 in two significant figures. We have question 2 is a question about gravitational field strength, and you are supposed to define what we mean by the term gravitational field strength, and this is force per unit mass. So remember, gravity is equals to force over mass, which is the same as weight, because weight is a type of force over mass. So that's why we're saying force per unit of mass, because weight is a type of force. Now, if you're told to define that, that's exactly what you ought to say. Force per unit mass experienced by an object which is in a gravitational field. An object has a weight of 42 on the surface of Earth. So we are supposed to calculate the weight of the object in the surface of mass. So something you need to know is that the mass on Earth is equal to the mass in mass. So we were to use this value that we have here in order to calculate the mass of this particular object, and that's going to be weight over gravity, and that's for Earth, which is going to be equivalent to 42 over 9.8, and that becomes 4.3 kilograms. And now, getting the mass as 4.3 kilograms, we are going now to substitute that mass and gravity of mass, which was given here. This is gravity of mass, which is 33.7. If you work it out, you'll get the weight in mass to be 16 newtons. Then we are supposed to calculate the volume of mass. Of course, we were given some data here. And in order to calculate the volume of mass, we need to use the density, and also we need to use the mass of mass, planet mass. So you must remember that density is equals to mass over volume, but to rearrange this, we'll have volume to be mass over density, and if you work it out, you are going to get 1.6 times 10 to the power 20 meter cubic. We have another question. There was a force acting forward that way, 30 newtons, and we are told that it's moving at a constant speed. So if it's moving at a constant speed, it means there is no resultant force. The two forces are balanced, so which means that the backward force must be a force of also 30 newtons. So that's what you are supposed to label on the figure. Resistive resistance of mass is less than air resistance on Earth, and then you are supposed to say how this is going to affect the resultant force of the bag on mass. So that point you have to remember that resultant force will increase here. Resultant force will increase because if the resistive force is less and the driving force remains 30 and the resistive, all the backward force is less, it means that now resultant force will be greater. And the relationship between resistive force, driving force, and the resistance is that resistance is obtained by the formula driving force minus the resistive force. So basically that's what you are supposed to answer in this particular question. We have question 3, and question 3 is about energy transfers, and in this case here we are told to describe energy transfer in the solar cell. Remember, the solar cell is absorbing energy from the sun, so which means that electromagnetic radiation will be converted to electrical energy that is going to run this voltmeter or the load that is going to be placed here. From the sun we are going to get radiations, which then this particular the cell is going to convert. Suggest how the black coating allows the solar cell to transfer more energy. So black is a good absorber, so that's what you ought to remember, that black is a good absorber, so more electrical energy will be transferred. You are also to remember about the question of efficiency in this part. Remember, efficiency is power output over power input times 100. So since the efficiency, the input was this and the efficiency was 75%, so we can just easily find the output by doing substitution, and if you work it out clearly, you're going to get your answer as such. State the meaning of the term kilowatt hour. This is kilowatt hour is the energy transferred in 1 hour. So you may find that which is the amount of energy transferred in 1 hour and at what rate. So kilowatt hour is amount of energy transferred in 1 hour, the rate of 1 kilowatt. Yeah, so we had also a question to determine the number of cells, and first we were to work out energy produced in 1 year. So I used the cells, the kilowatt hour that was in this particular part, the output, times 6 hours, which is the available time per day, times 365. So if you work it out here, you get 1182.6. But number of cell now will be the energy, because remember power is equal to energy over time. So number of cell will be the energy divided by 1182.6, we get 6.26, but now that translates to 7 cells. We shall pick from question number 4 in part B, and if you are new to Proflan YouTube channel, consider subscribing so that anytime we're going to do more tutorial, you'll be notified. Check in the description for part 2 of this video to the last question.